Okay, what we're doing today is we are using Pascal's triangle to find specific terms. So before we were using it to expand, but now sometimes you're going to have to answer questions where it wants the second term or the third term. And so there's a process you can use so you don't have to do the whole problem. So the first thing I need to do is figure out where I should be going. So I'm going to get a highlighter. For this problem right here, I'll do in yellow. So the fourth term tells me the fourth row should be right here. And then I'm doing the second term, which is right here. And so that's the main number I'm going to be focusing on. You could still write a little bit more, but really I just have to do, sometimes I'll do this. I'll draw two blanks. This is the one that I really want because I want the second term. So I know my numbers 1 and then 4. Now, the reason I draw the two blanks because it helps me remember what I have. And so remember, if I wrote this would be x to the x to the fourth. And then I go over, this is x to the third. Well, the next thing that I should know is that my other term is 5. And if you remember that trick, our exponents have to add up to this exponent here. So this has to be 5 to the 1. Because I have 3 here and 1 here. So this is what I would have if I would have written out my whole expansion. And now I just need to do my math. So 4 times 5 is 20, and then x to the third. Okay, so again, I found my row. I listed my terms till then, and then I went from there. Okay, I'll highlight this next one a different color, maybe purple. That sounds like fun. Okay, so here's this one. And so now the fifth term on the fifth row. So here's the fifth row. 1, 2, 3, 4, 5. Now when I'm on the right side, I'm not going to draw all of them on the left. I'm just going to draw them from the right. So there's the 6th, there's the 5th, which is a 5. This one's a 1, and then I'm going to go here. Now, if I was on the left side like I did here, I'd start with the first term. But since I'm on the right side, I'm going to start with this term, the second term. And so remember, it's 3 to the 5th, and then 3 to the 4th. And so now I also have to find out what my exponent is on the other one. And remember, our exponents have to add up to here, to 5. So if there's 4 on the second one, then there is 1 here, because I have to add up to 5. And so now I have to do 3 to the 4th, which is 81, and times it by 5, and that is 405x. And that's the answer. Okay, the last type we are going to have is when there's two numbers. Let's get one more color highlighter. Let's go with green. And so this time I'm doing the 6th row again, and it's 1, 2, 3, 4, 5, 6 terms. Okay, so it's the same process as what we did here. What I'd like you to do is I'd like you to pause the video and try it out and see how you do. And then when you think you're ready, press play again. Okay, so welcome back. You probably started off by doing this step, and then I'm honing in on the 6th term, which is a 6. And so this would be 4 to the 6th, and so this is 4 to the 5th, which means this is 2x to the 1. And so now 4 to the 5th, oh, that's a big problem. Let's try that on the calculator. That is going to be 256, and then I times that by 2, and then I times that by 6, so it's 3,072, and then x. There is one thing that I forgot to talk about. We didn't talk about any negatives, right? And the first problem has a minus and the last problem has a minus, so we have to look at this. If I have -5 to the 1 power, that means I have 1 negative, so this should have been a -20. Sorry I didn't catch that right away. I forgot about it. It's early in the morning. And then over here, same thing. This would be a -4, and I have 5 of them, and so 5 negatives. If I listed them all out, 1, 2, 3, 4, 5, those are the ones that would become positive, and so I would have a negative here also. Okay, so if you're not sure, you could list them out that way, like I did here, and that would help you. But if you have an even amount of negatives, it would become positive. Odd amount of negatives are negative. Okay, so try this strategy of boxing it in. Remember that the exponents here have to add to the exponent in the problem, and then you should be able to find your term.